So I totally messed up, and I apologize for that, on a different video, which you guys never saw. But anyways, I want to show you guys how to factor a perfect square trinomial. So when we talk about a perfect square trinomial, we want to talk about squares. So let's go and take a look at one of the ways I showed you guys how to factor. And let's say we have the number 16. Now, if 16 was a rectangle, we know that two side lengths could be 2 times 8, right? Because remember, when we're factoring, we're saying, here's our product, but then there's our factors. But what if 16 was a square? Then we know, remember, square has equal side lengths. So therefore, the side lengths would have to be 4 times 4. And that's very important because now what we're going to be looking at is when we think about factoring, we're given the product and we want to find the side lengths. Well, when we're factoring these quadratics in standard form, sometimes we don't know, is it a perfect square or not? So what I'm going to do is I'm going to show you how to find a perfect square and then how we can factor it depending on that. OK, so when we look at this, the main important thing that we want to understand is to make sure that we are dealing with a perfect square. So when we're looking at y equals ax squared plus bx plus c, we want to make sure c is a squared number. That means we can take the square root of it and get an even number. So what I did is I wrote out our square numbers all the way up to 15. You can see 9, the square root of 9 is 3, or you could say 9 equals 3 times 3, 8 times 8, 11 times 11, and 15 times 15. So I did all of them up to 15. So whenever you see any of these numbers in for c, that means we have a possible perfect square trinomial. So this has to be a square number. All right? Then the other part for dealing with the square number is our b has to be double the square root of c. So when I'm looking at a perfect square trinomial, the first thing I do is I look at c and I say, all right, is that constant, which we call our c, our last number, is that a square number? Is it one of these? And if I say yes, then that's good. Then the next point is I look at b and I say, all right, is my b double the square root of that number? And if it is, then I have a perfect square trinomial. Now there is a couple stipulations. C has to be positive. If my square number is a negative, then it's not going to be a perfect square trinomial. So as long as c is positive, our b can be positive or negative. Because think about it. This can be 3 times 3, but it can also be negative 3 times negative 3. Either way, it's always going to produce a positive value of 9. However, it can add up to a negative 6, or it can add up to a positive 6. So our middle term can be positive or negative. And let's just go and take a look at, let's look at an example. If I had y equals x squared minus 6x plus 9, and I had an example y equals x squared plus 6x plus 9. So we see that 9 is a square number, and the square root of 9 is 3. And then you can see b is double 3, which is positive 6. Or here, b, a negative 6, is double a negative 3. So therefore, these are two perfect square trinomials. If I was going to do maybe the x method, you could see that I'd have 9 and 6. Therefore, there has to be 3 and 3. Over here, I'd have 9 and negative 6. So my p and q would have to be negative 3 and negative 3. So when we're dealing with this, b can be plus or minus, but my c has to be a positive. All right? Then what's going to be really important about it is if this is b, when I factor this into my factored form of x plus or minus q times x plus or minus p. So my factors are going to depend on, my factors are going to be positive if my middle term is positive. They're going to be negative if my middle term is negative. So when I factor this, what I want to do is take a look at, all right, as long as this is a perfect square trinomial, and this is double the square root of that of c, that perfect square number, then if it's positive, my factors are positive. If it's negative, my factors are negative. So ladies and gentlemen, this can be a very, very quick process, and I'll show you some example videos on how to do this, where what we're going to do is we're just going to look by inspection. Look for a square number, look for double the square root of that number, and then quickly write out the factors without having to go through the factoring by the box or factoring by the diamond method. Thanks.